The stationary process is nothing but the statistical properties does not change with time. Okay. So for a random process, if the statistical properties does not change with time, then that particular random process is called stationary process. So we have discussed that the statistical properties depends upon PDF function. Okay. So since PDF is having different levels, okay, it is having different levels. So the stationary process also have different levels or different orders. Okay, this we have discussed. So a random process is said to be stationary if its statistical properties does not change with time. Okay. So here the first one is the first order stationary process. In first order stationary process, the first order probability density function does not change with time. Okay, it does not change with time. And what we have discussed here, we have discussed that the expected value of the random process, that is x of t, E of x of t is equal to x bar is constant here. For first order stationary process, what is that? The expected value of a random process is constant. Okay. And we have discussed what is second order stationary process. So in the second order stationary process, the second order probability, the joint probability density function, because second order, no. So we'll be having second order joint probability density function. That is, we have two random variables here. Okay. We denote like this, and this does not change with respect to time or shift in time. Okay. What is the condition here is the autocorrelation function is function of tau. It is not function of t. Okay. So this is the second order stationary process. And we also discussed what is wide sense stationary process. In wide sense stationary process, we have discussed that. So wide sense stationary process is also called weak sense stationary. It is also weak sense stationary, and wide sense stationary process is second order stationary process. And here it will be satisfying two conditions. The first condition is, so this one, the expected value, that is mean of a random process is constant, so it is equal to constant, and it will also satisfy the next condition that the autocorrelation function is function of tau. Okay, if these two conditions are satisfied, then we say that this particular random process is called wide sense stationary random process. Okay. Then we have jointly wide sense stationary stationary process. So in the jointly wide sense stationary process, so we have discussed that. So it is also satisfying these two conditions. What is that? The expected value of, because we will be taking two random processes here, x of t and y of t. These two random processes are said to be jointly wide sense stationary. If these two random process, whatever we are taking, x of t and y of t are the two random process we are taking, no? These two random process should be wide sense stationary, and this the joint, what is that, cross correlation of these two should be depending upon tau. Okay. So it means that these two are wide sense stationary, means that expected value of x of t is equal to x bar, that is equal to constant. It has to satisfy this condition. Then expected value of y of t is equal to y bar, it is equal to constant. It has to satisfy this condition. Then the autocorrelation function is function of tau, and the autocorrelation function for y, it is also function of tau. The third condition is that the cross correlation should be function of tau. Okay. So if these three conditions are satisfied, then these two random processes are said to be jointly wide sense stationary random process. Okay. And the fifth one is strict and stationary. Strict and stationary random process. Okay. So in strict and stationary random process, we are taking a random process x of t, which should be here we have to consider n-dimensional joint probability density function. Okay. So we are taking n-dimensional joint probability density function. This function should not change with respect to time or shift in time. Then this particular random process is called strict and stationary random process or n-dimensional stationary random process. Okay. So what is the joint probability density function of n dimensions? So here it is fx of x1, x2, so on, xn. How do you get this? We are getting this at time instance t1, t2, so on, tn. These are the time instance where we are getting this. Okay. This n-dimensional joint probability density function does not change with time or shift in time. Then this particular random process is called strict and stationary random process or n-dimensional stationary random process. Okay.